Effects of climate change. Climate change in the Arctic. Average air temperatures in the region will have increased by about 5 degrees Celsius over the last 100 years. Recent data shows that there'll be almost no summer sea ice cover left in the Arctic in the next few decades. The effects won't just be felt by the habitats and species such that rely upon this area, they'll be dramatic in the entire northern hemisphere. Climate change and oceans. Oceans are vital carbon sinks, meaning that they absorb huge amounts of carbon dioxide, preventing it from reaching the upper atmosphere. Increased water temperatures and higher carbon dioxide concentrations than normal, which makes oceans more acidic, are already having an impact on oceans. Oceans are already experiencing large-scale changes at a warming of 1 degree Celsius, with critical thresholds expected to be at least 1.5 degrees Celsius and above.
Atmospheric composition: nitrogen makes up 78.9%, oxygen makes up 20.95%, argon makes up 0.93%, carbon dioxide makes up 0.038%. And there are minute traces of neon, helium, methane, water vapor, krypton, hydrogen, xenon, and ozone. The atmosphere is composed of a mix of several different gases in differing amounts. The permanent gases, whose percentages do not change from day to day, are nitrogen, oxygen, and argon. Gases like carbon dioxide, nitrous oxide, methane, and ozone are trace gases that account for about 1% of the atmosphere. Water vapor is unique in that its concentration varies from 0 to 4% of the atmosphere, depending on where you are and what time of the day it is. In the cold, dry Arctic regions, water vapor usually accounts for less than 1% of the atmosphere, while in the humid tropical regions, water vapor can account for almost 4% of the atmosphere. Water vapor content is very important in predicting weather. Greenhouse gases, whose percentages vary daily, seasonally, and annually, have physical, chemical properties which make them interact with solar radiation, and infrared light given off by the Earth to affect the energy balance of the globe. That's why scientists are watching the observed increase in greenhouse gases like carbon and methane carefully, because even though they are a small amount, they can strongly affect the global energy balance and temperature over time, as humans are increasing it, producing the enhanced greenhouse effect, which is one of the contributors to global warming.
I'm Batman.
Yeah.
So what are the causes of global warming? Well, so it has something to do with greenhouse gases. You see, the sun emits heat rays, I think, that go to the earth, and some of them bounce back out. But with the greenhouse gases, such as like carbon dioxide and methane and stuff like that, some of them get trapped, which is not good. I don't want that. So, yeah. And when they get trapped, it heats up the earth. Methane is produced from cow farts, basically. And CO2 is produced by humans mostly. And animals as well. Well, mostly humans. And plants, when you think about it. Because humans, plants, animals, we aspire. But plants do more photosynthesis, so it's a bit better. But yeah, and because of like industrial sites are emitting a lot of CO2, it's kind of difficult for plants to like balance out the CO2 and the oxygen. So we are facing increasing CO2 levels, which is like not good for humans, and also is not good for our planet. And those are the causes. I'm going to go to the gases a bit more. So, yeah, I think I've covered the CO2 and the gases. CO2 and the gases, what I'm on about. The causes and the gases, I think, yeah. And it's also something to do with like the tilt of the Earth. That's, yeah, heating it up for some reason, because it's like periods of cooling and warming, but we're going through a phase of warming. So yeah, that's literally all I have. And there's gonna be no editing in this bit. That's great. Need a proper mic. Alright, I'm done.